In this example, I'm going to show you how to test the population proportion using critical value method. A recent study claims that less than 15% of junior high students are overweight. In a sample of 160 students, 18 were found to be overweight. At alpha equals 0.05, test the claim. The first step is to state the null in the alternative hypothesis. HO and HA, it's a proportion test, so put P and P. We're testing if the percent is less than 15%, so that will be 0.15 right here, and this is where the claim is. The null hypothesis is always the equal sign, which is what? 0.15. Now, before we proceed to the next step, we need to check that the requirements of the test, the proportion Z test, are met. So we need to check if N PQ is greater than or equal to 10. So N is the sample size, which is 160. P is the assumed value in the null hypothesis, which is 0.15. And Q, it's 1 minus P, which is 1 minus 0.15, which is 0.85. And if you do the math, you're going to get a number greater than 10. The next step is to find the test statistic, standardized test statistic. It's called in the book Z0, sub-0, which is P hat minus P divided by square root of PQ over N. Now, what is P hat? P hat is the proportion from the sample, which is X over N. X is the number of successes, so the number of students who are overweight, and N is the total number of junior high students. So we have what? 18 over what? 160. If I do the math on the calculator, I bring the calculator close to here, and I do 18 over 160, I get 0.1125. Okay, so to find the test statistic Z0, we do 0.1125 minus 0.15, which is the assumed value in the null hypothesis, divided by square root of 0.15 times 0.85, which is Q, divided by N, which is 160. Go ahead, guys, and calculate this one and make sure that you do this one right. I got about negative 1.33. Okay, step number 3, we're going to sketch a diagram showing the rejection region of the null hypothesis and the non-rejection region. Okay, so here's how you do it. P is, the alternative has a P less than 0.15, so it's a left tail test. Our rejection region is going to be on the left because we have a left tail test. This center value is 0 always. I need to find this, which is called the critical value. And in order to find this, you only need this level of significance, which is, this area is the level of significance, which is 5%, 0.05. If you are using your calculator, you want to find this value, you just put, it is the inverse norm. You put the area to the left, which is 0.05. You put 0 and 1, and then hit enter, and your calculator is going to produce negative 1.646, I believe. So that will be your critical value right here. And you can use table 5 as well to find this critical value. Just go inside the table and look for the value 0.05, and then try to read the z-score from there. Now, what was the test statistic? If I go back, my test statistic was negative 1.33. Place the test statistic on the number line and see where it falls. Negative 1. This is negative 1.645. Negative 1.33, you would agree with me, it should be on this side, which is a z0 equals negative 1.33. Now the region that I shaded is where we reject HO, and the reason that I did not shade is the region where we fail to reject HO. So our decision here, because Z0 fell in the non-rejection region, we say fail to reject HO. My claim is in HA. If I fail to reject HO, I cannot support the claim. Cannot. So what do I write here? Step number 5 is to interpret your decision in the context of the claim. So you write, there is not enough evidence at the 5%, which is a 0.05 level of significance. What is the level of significance? The level of significance is the probability of making a mistake, of rejecting HO when it is true. There is not enough evidence at the 5% level of significance to support the claim that the percent of junior high who are overweight is less than what? Whatever it is in the problem, less than 15%. So this is how you use the critical value method to test proportion.